Hi, welcome to this video. In this video, I'll be talking about one-way analysis of variance, Anova. This will be to compare two or more populations for independent samples, and it will be for interval data. We will be looking at the following example. An MBA student randomly selected four recent graduates, one each in finance, marketing, and management, and asked them to report the number of job offers. Can we conclude at 5% significant level that there are differences in the number of job offers amongst the three MBA majors? We have the data provided here. We'll start by writing down the null and the alternative hypothesis. The claim is there are differences in the number of job offers amongst the three MBA majors. So this will be the alternative hypothesis. At least two of the means are not equal. The null hypothesis will be all the three population means are equal. Next, we'll take the data into Excel to analyze it. Once the data is in Excel, we go to Data, Data Analysis, then we click on Anova, Single Factor, and then OK. In the box, I'm going to highlight all three of the columns. It will be grouped by columns. My alpha in this question is 0.05, and then I'll click OK. The result shows up here. Now I'm going to be using the results from this Anova table to perform my test. From the table, I can see my test statistic, which is 4.82 in this case. And I can find my critical value from the F distribution table, or I can go to any cell in Excel and type this formula in. My alpha, the area on the right tail, is 0.05. My numerator degrees of freedom is 2. I can be able to see that from my table. And my denominator degrees of freedom is 9. So when I use the F distribution table or I type this formula into any cell in Excel, it returns the critical value. I can also be able to see the p-value right here in this table. Now, if I compare the test statistic, I will see that the test statistic is greater than the critical value. So I reject the null hypothesis. If I use the p-value, I'll see that if I compare the p-value to alpha, it is less than alpha. So I will also be rejecting the null hypothesis. I can thus conclude that at 5% level of significance, we have sufficient evidence to support the claim. Again, the claim in this case is the alternative hypothesis. Thanks for watching this video.